we've been doing so far is all that powerful when all we've been saying is hello world. And in fact, I hard-coded the word.
So there's a number of functions we have on the screen there, and I will say from my own first experience with CS50 or in programming in C generally, one thing that's really annoying is input-output in C. It can be really difficult to get used to, especially because in order to do it correctly, you usually have to use pointers, which we don't want to talk about.
Yeah, to allocate a buffer or at least allocate an array on the stack, and even then you're vulnerable to buffer overflows. Yeah, no, this was something that we inherited from Eric Roberts from Stanford had put together a library, genlib and simp.io, and he's ported those to other languages as well, that we, Glenn Holloway and I from CS50 weaved into our own CS50 library where we changed the documentation and the code itself a little bit, but really just to give students some standard set of training wheels at the start of the semester, really so that we can focus on getting input from the user and not tripping over ourselves trying to explain why, well, you technically need to give yourself an array first and then put this, like it's just too much distraction. We
want getting mired in scanf and having to have extra parameters to make sure that stuff doesn't get caught. And
which scanf isn't bad for things like integers and whatnot, but as soon as you start to have, if the user types more characters than you expect at the prompt and then hit enter, then it buffers up and then you see it on the next request and it just becomes a mess.
Yeah, I mean, even having this discussion right now, if we were having students see this early on, it could feel overwhelming talking about scanfs and buffer overflows.
Yeah, I mean, we're way ahead of ourselves now. So these, I think, are compelling training wheels, and that we, again, consciously, like almost everything in CS50, take off eventually mid-semester when we context switch and really start doing things at a slightly lower level. But I think early on they help us. I think other languages suffer from this as well. I mean, even before Java had the scanner class, and even now, like there's a few lines of overheads that like actually just get simple input from the user. The big change we did make this year was fixing or changing to be more standard our capitalization of these functions. For 9 years, we used capital G, capital S for getString, and so forth. And that was because those were the names of the functions in the original libraries. But even I think Eric has since gone back in and changed them to be a little more consistent snake case-wise with C. And we have ports of the library now to other languages where we've made the naming scheme language specific, right? Just as to preach best practices. And indeed, that was thematic this whole year with CS50's videos, to go back through and really do some spring cleaning, remove material that had just gotten a little bloated, but also make sure we were doing as many possible things right, or at least in the most standard way possible.
Teaching sort of best practices as well as teaching concepts and
exactly.
skills.
So as to not accidentally send some wrong message. Of course, that meant having to redo every one of our resources, especially the older videos, but that's okay. I think we're staying current. And what better time than when we're switching to version 2 of this new environment for us.
Right. Now, in addition to the functions that we use for I/O, we also made a conscious effort to include some more debugging functionality in the CS50 library this year, which allowed us to teach it debugging concepts much earlier in the semester than we've been able to do in the past.
Indeed, and we don't have to care about this at this point in the semester, but now the CS50 library, thanks to some attributes that Clang, our compiler, supports, does its own garbage collection or memory management, so that in years past, when you would call getString, every string you would get back would be leaked, essentially, because you never actually called free, unless we then later told students, by the way, you should really be calling free on your strings. And that's really breaking the abstraction barrier that an API is supposed to provide. Like, if you're giving me a string, I should not have to like do your cleanup for you. I'd much rather the library, in that case, do it. So the library now does that memory management for us, which is nice. But it also has eprintf in it too, which we promoted this year as a function that's pretty much just like printf, but for printing errors is eprintf. And what it does is it magically, using some macro tricks in C, is it prepends your line of output with like the file name and the line number.
And it also prevents the output from being buffered, which can sometimes happen with printf, which leads to sort of red herrings about where exactly the error is coming up in your program.
For many years in office hours, we would have students write some line of code, and when trying to debug their code, they'll like use printf to print something out, but they might forget to include like a trailing new line, which typically, as a side effect, flushes the standard out buffer. And so the result would be that students would have some bug in their code where maybe it gets stuck in some loop, but the thing they're trying to print here, even though you're well past that point logically in your code, never got flushed, and so you never see it. And so they waste time in office hours, for instance, or at home, wrestling with a bug in the wrong place. So now we just make every character print the moment it's sent to standard out and standard error.
Hopefully that helps to reduce the number. There. Certainly at office hours this year, we saw a lot less of that kind of thing.
I think a good subtlety to understand eventually, but not to not understand and get tripped up by when you're really trying to focus on actually solving some problem of your own.
Right.
Whatever the user has typed in at his or her keyboard in a variable called.
You notice that's how I type.
And it turns out that printf
like that.
Apparently, that's what my what I think during lecture is typing.
2 or 3 more, such that the second or third or fourth